This is the Nice Power 30 volt 10 amp switching power supply. You can kind of see what it says right there. All of these switching power supplies of this particular form factor and price range tend to be white labeled and then sold by various retailers. You'll get yours. It has, I like how they're packed. This is pretty good packing. You have, yours will have a little piece of tape on it. There's cutouts here for the feet, and then on this one there's an L-shaped cutout for the controls, and then cutouts for the feet in there as well. And it comes with your plastic bag. It's got a little piece of tape on it. We'll stuff that in here. And here it is. There it is. I've already taken the film off the front of it. Some people call this a kettle cord. It's an IEC connector, standard power cord. Here, plug it in, take a look at it. We'll get it on the bench a little later in the video here. Put it through its paces. Okay, so let me turn it on. There it is. It says 32 volts. I think this one might actually go. Now this one here, you turn the coarse, and then when you get it where you want it, then you turn the fine to precisely, you know, if you wanted it to be 20 volts, you'd have to turn the coarse down a little bit. There we go. And once you get it dialed in, it's pretty good and stable. We'll show you that on the what you call it, on the bench when we get to that. So here's our amperage here. I set my fine in the center. I set my amperage. Want it to be exactly 10, so I'm going to get it down a little bit. There, I got it at 10 amps. But what I usually do is I just usually keep this maxed out, so it's like 10.2, 200ths of 0.2% greater than whatever, it doesn't matter. So this is probably this is one of the ones I'd recommend for people who are starting. I have another one that's 120 volts. That one's good too, but typically most people don't need 120 volts. This will give you 30 volts, 10 amps. That's a lot of current, especially if you're just working with Arduino stuff, trying to do a little bit of robotics. The 10 amps is great if you've got motors, if you've got something that, you know, there's a heater, you know, that kind of thing that really is going to draw some current. But I want to show you that these are all essentially white labeled. They're the same circuit inside, the same form factor. And then we'll get it on the bench. There's this little button here. This turns the output on and off. We turn the output on. This is a lot bluer of a green. It's not a warm green. It's kind of a cold bluish green. There you go. So you can see that these are all very, very similar, just even in appearance. This one in front here is a 30 volt 10 amp, and the two in back here are both 120 volt 3 amp. And really, the only difference is, you know, there's very little difference in what these are internally. The circuit board layout controls, so they have a plastic control panel. This one here is one that has push buttons on it, so you have a digital encoder knob. You have two knobs. Each of them is a digital encoder, and you select which digit you want to set. This one here has, instead of digital encoders, this has potentiometers, a coarse and a fine for each one of them. But the boards are, you know, the whole thing is really, really similar. You know, the back end of it here is where you've got your cooling fan, and you got your power connectors, combination fuse connectors there. Same thing with these here. This other one, I'll just move this kind of aside here and show you. You know, you got your same exact thing. So these panels are actually somewhat interchangeable. Circuit board configuration is almost identical, and you'll see that there's just a flat heatsink back here. There's no fins on it. There's no cutouts. Nothing. you'll see that the the output transistors, the power switchers are here. They're exactly the same. This is the 10 amp version, and this here is the 10 amp version, and these are the 10 amp 30 volt, and this one here is the 120 volt 3 amp version. So they even have very, very similar, just everything is very, very similar. All right, so let's put this power supply through its paces. This is the 30 volt 10 amp power supply. Got it at 20 volts here. I'm going to put it at exactly 20 volts. Let's see here, get it up to 20 volts. There we go. Dial this into exactly 20. Now this one has the potentiometers on it, so you got the coarse and the fine. Takes a bit of playing, and then I'm just going to turn the bottom one all the way up here, so we're certainly on constant voltage. Set the scope up here. So I have the scope set to half a volt per division, and when I turn this on here, turn the output on. There we are. Got 19.98 on the meter here, 20 here. I'm going to put a 2 amp load on it here with the electronic load. There's 2 amp load. It's running fine. If I bump this all the way up to 30, I have the scope set here just to say I should put it back down at 20 here and just show you what's happening on the scope. I wasn't even paying attention to the scope, so let's see here. You got it down to 20 volts. There we go. So if I turn the load off, you'll notice that we do get some noise like right away. If I turn the output of the power supply off, then there's our scope. Now the scope is set up to block DC right now, but when I turn this on, I do get noise. So now I got it down to 30 volts. And if I put the load on here, there's 2 volts, or 2 amps. Now notice that this is 2.95. I have no idea what that is. If I change the load on it, now the output, the ammeter on the power supply starts to read right. I'm at 1.9 on the load. If I bring it up to, say, 2.5 here, there's 2.5. And I go all the way up. So now I can go up to like 10 amps. There, let's bring it up to 8, 9. There's 10 amps. There's 10 amps. All right, so I got the scope hooked up here. And I'm basically looking at the frequency of the largest spikes, and I can actually measure that. So I have the scope set up now, and what I'm doing is I'm using the vertical cursors here to measure the frequency of the cycle between the largest spikes, what essentially appears to be the repeating pattern. And I don't know if you can read this on the video, but it's actual 34.97 kilohertz. So it's about 35 kilohertz there. And if we look at this live, so there you go. That's with we're drawing 5 amps now. The cooling fan actually is kicked on the power supply, and if I take the load off of it, now you can see what you have for noise there on the scope. Bring the load back. This is what happens when it changes the noise profile. So if I turn the output of the supply off, now you can see that there's really no AC on top of that. The scope is just getting like nothing. Maybe a little bit of noise, environmental noise. And then when I bring the load back in, what I'll do is I'll reset the stats here. and this is about average of 670 or so millivolts on top of the millivolts of DC on top. I'm sorry, of AC on top of the DC. I can go into all the setup that I did on the scope, but I don't think anybody would be that interested in it. But you can certainly see that's where the noise is, and the scope is showing us the noise. So that's my biggest reason not to use a switching power supply is that noise. But for most applications, especially if you're using like microcontrollers, robotics, simple circuits, switching circuits, that kind of stuff, even audio, this power supply is going to do okay for you, because this this noise is out of band for those kinds of applications. I like a linear power supply for some of the more delicate work that I do, but there's absolutely nothing wrong with this. And if you don't have a power supply, this is a really, really good price point to get into, having a power supply.
Through the circuit, and on this case I've got a high and a low beam bulb, and you mean now it's not going to work? I just had this thing I was just testing this thing working. Oh, that's because you know what? I'm not on ground. There we go. So this is great. What I like about this too is it's telling you how many amps it's sucking down, how many watts it's sucking down. That's pretty cool. That's actually way nicer than just, I don't have to have a meter on this. I've got it built in. So that's pretty neat. My only niggle, and this is just for charging up phones, is why couldn't it have been a 5 amp charger for your phone, USB? That's a small problem. Anyway, hey, this is pretty cool. Clip that back on there and say, yeah, we got a nice little power supply there. That's pretty neat. I tell you what, these things range in price. This one's a pretty good, they all seem to be very, very similar to one another. I can't speak to the more expensive ones, but I tell you what, I like this. This is cool. Good value, Amazon, good value.
Watch the oscilloscope.